Hey, I hope you're able to see this. So here we are live on YouTube too. There was some interruption in between, but it's cancelled now. Error is vanished. So yes, we are already live. Got it? Fine? Yes, we are live. Okay. So cool. That's cool. Yes. So we were on the third topic. I mean, the second is completed, and that is some important terms. Then we have seen plane mirror and light interactions. Okay. What is plane mirror? How it interacts? I mean, how light interacts with the plane mirror. Then we study about the spherical mirror, okay, and some important terms which are related to the spherical mirror. What are the some important terms that we'll see again? Okay. I mean, in your class, this topic was not completed. Am I right or wrong? Your topic आपकी class में was completed or not? Please reply in the chat box. Spherical mirror. Was this topic completed? No, no. Varsha says no. Okay, cool. Fine. Sneha says nope. Okay. So we'll start here now. Okay. So this is the contents of your today's class. What are the contents of your today's class? Today we'll start spherical mirror. We'll understand about that. What is spherical mirror? We'll understand the types of spherical mirror. Two types basically. We'll understand that. We'll understand some important terms which are related to the spherical mirror. And then at last, by using all this knowledge, theory, concepts, we'll apply this as an application for solving the numericals. Got it? So this from 1, this from 2, this from 3. This is our today's class flowchart goal or goals today's. Got it? Fine. Okay. So let us first see some of the revision part quick. देखो ये मैंने 1000 बार बता दिया. Like I have this explained you 1000 of the times, isn't it? Yes or no? बहुत बार बताया ना ये. Yes. So from this we concluded about many things, that some things are known as sources of light, whatever, blah blah. Then we've seen that this is rays, and rays something a straight line in the direction of the light. Okay. Then we have studied about the optics, that it is a branch of physics. By the way, in the beginning only I've told you this thing, that this optics is not just ray optics. I mean, optics is particularly the branch of physics, and it is divided into two: ray optics, okay, wave optics. But for now we are studying the ray optics. Okay. Then we studied about optics thing. Yes. Then we studied we understood the complete meaning of the definition of ray optics. That in this ray optics, we're studying light as a ray, interaction with matter, and phenomena, reflection, refraction, and all these things. Okay. Then we studied the properties of light. We have already seen this thing. Then we have studied, we have seen the electromagnetic spectrum thing, that in electromagnetic spectrum, basically, our light covers the region which is from this wavelength 400 nanometer to this wavelength that is 700 nanometer. Okay. After this, we have seen some important terms as a ray, that what is known as ray here. Okay. So here we can say a ray can be defined as imaginary line drawn in the direction in which the light is traveling. What is ray? Ray is defined as an imaginary line drawn in the direction in which the light is traveling. So this is what? This is source. This is what? Receiver. So it's a light ray. Okay. Then we have seen after that what? We have seen some important terms like beam. What is this beam? Beam. It's not Shinchan beam. You have seen Shinchan beam? Shinchan, anybody have seen animation? Okay, leave that thing. So what is this? Let us revise and don't waste time. Beam is what? Beam is something like collection of rays. It can based on the position of the rays. Yes, based on the position of the rays, three type of beams are there. Okay, parallel beam. What is this? Parallel beam, convergent beam, and divergent beam. One which converges at a point is convergent beam. One which diverges from a point is divergent beam. One which is parallel, collection of rays which are parallel is parallel beam. Then this we have seen that this is the process of phenomenon of reflection shown by these rays, at a ray which goes like this as incident at any angle I and reflects like this. We're following the laws of reflection, where this we have seen students that incident ray, normal, geometrical normal, and this reflected ray all lies on same plane mirror. Okay, and where this I is known as angle of incidence, R is known as angle of reflection, and G is here glancing angle. O is at a point of incidence. Okay. So this was the phenomenon of reflection. Then we have seen some the school pics, and then like what? Plane mirror, we studied about plane mirror, we studied these laws of reflection. These are basically what? These are two laws of reflection. Okay. Okay, so my voice is breaking. Okay, let me close you. I close the video. Is now it's breaking. Now it's fine, Anna. It works now. Yes or no? Okay, good. Pooja says yes. Okay, all the students say yes. Good. So now after this, we have seen, yeah, we were at this point in the class. Okay, that relation between velocity of object and image. Okay, so have we derived this thing? Yes or no? इसका derivation किया था? Have we derived this thing that I use this funda as a concept to derive the relation between when a helicopter object is moving, a mirror is moving with velocity vm, and an image is also moving. Then we derived the relation. Got it? Yes, sir. Okay. So what about the relation? Okay, now we'll start with the whiteboard. Okay. Now we'll study in the whiteboard. Let us make the class look like offline. So now I have shared in front of you a whiteboard. Are you able to see it carefully? So now we'll make us like it will be like an offline class for you. Okay, so I want you to feel the class is offline. So I will write with you everything. So from now, write the notes properly, okay? Because this is the main part from where the optics start. And you'll find many questions in GRE, some good examples like JAM, many in the future. Also in the ITG, KCT, NEET, questions based on from this topic, which we are going to study now. Got it? Is it right? Fine. Okay. See, students, we have seen basically, okay, let us revise little bit of the part of the previous key. Oh, sorry. So this you have to erase. This is plane mirror. Okay. This was the object. Suppose it's a flower. It's magic flower. Suppose it's like a magic flower. Okay. Let me color this inside. Yellow color. Okay. Somewhat green color. Somewhat light green color. Fine. Now suppose this is a magic flower and it is moving with velocity VO towards x-axis. Okay. And this is a mirror also. It somehow moves like this Vn speed. And of course, this object which is at a d distance, using this concept, that is perpendicular distance of the object from the mirror is equals to perpendicular distance of the image. This will be the image. Okay, so this image will be also moving with some vi. I don't know, it may be negative or it may be positive, but we have used a funda which, what was that, velocity of object with respect to mirror is equals to minus of velocity of image with respect to mirror. Sir, ये हमने कर लिया. Okay, so let us revise the formula. Just velocity of object vectorly, okay, vectorally, okay, velocity of object velocity of image upon 2 is equals to velocity of plane mirror. This was a relation we have tried at the end, and this you will use for solving the questions. Okay, now suppose I give you a question like this. This is a plane mirror. This is a plane mirror. A object is in front of the plane mirror. It is moving with some speed which is, say, 3 meters per second. And the mirror is moving with some speed, say, 7 meters per second. So, इसका image भी होगा कुछ. What will be the vector? I mean, the velocity of this image I. Anyone can answer? Of course, you will take this as positive direction and this as negative direction. Can anybody answer, students? What is the velocity of this image? Any one of you? I want your answers now. This is a live question in front of you. What's the answer? Use this formula. No, we have to see. Use this formula. Okay, मैं करवा चुका हूँ ये. Okay, let me solve its answer. So it will be like this. Velocity of object is 3 meters per second positive. Velocity of mirror is minus 7 meters per second. Velocity of image is, we don't know. One of the students have texted minus 11. Very good. Sonali Pathak have texted answer. Let us see, is her answer right or wrong? So if I apply the formula, students, velocity vector upon 2 velocity mirror. So when you put the values, it will come like this. This here, this is a variable here. Okay, so now solve this thing. You will get what? So it will be like this: 3 plus vi. 3 is what? Positive. Twice of mirror. Mirror is what? Minus 7. That is 2 minus 7. Minus 14 minus 3. Sorry, your answer is wrong. So it is minus 17. So velocity of image will be this direction with 17 meters per second. See how much it changes. If the mirror is moving, object is this, it will be having 17 meters per second answer. Yeah, Anu has given the perfect answer. Sonali also perfect answer. And Shagun perfect answer. Priti Porna perfect answer. Okay, got it. Now, students, let us leave this thing and let us move towards the next topic of the class. Write in your notebooks with a very good handwriting. I mean, if you make the notes good, attractive for you people for studying, then you know what happens whenever someone opens your notebook. If the handwriting is very good, everything is like, you know, well designed, and like it looks very calm to eyes. So it also helps our brain in studying the things, even if you are not in the mood to study. But just by seeing that thing, our brain, like, it creates something inside, like we feel interest. Okay, so that is also a trick we can implement for studies. Okay, make a good notes. Okay, so focus here now. Write the heading spherical mirror. Write the heading spherical mirror. But first of all, text me. Are you having doubt? Whatever the things which we have studied, students, till now in the class, are you facing any doubt in that? Are you facing or feeling any doubt in that? You can text in the chat box. Got it? Spherical mirror. If not, just write this heading spherical mirror. Good. Okay. See, suppose, students, we are having a spherical glassy material. Suppose this is somewhat spherical Spherical glassy material. It's what? Spherical glassy material. Okay. And suppose this is the center of this material. Okay. Suppose students, if from this material extract little bit of this part, I extract little bit of this part and I put this part here in front of you. So I will get a what? I will get an arc like this, small part of the periphery kind of. Okay. If I polish this other side with silver polishing as I've done in plain mirror, I will get a mirror which is curved. I will get a what? Now I will get a mirror because this side is now reflecting and it's not reflecting and this is reflecting because it is polished. Okay. This side will be reflecting. So I will get a mirror. Okay. And this mirror is known as one of the spherical mirror. Can anybody give me the name of this mirror? It's known as concave mirror. Okay. Very good students. Very good, all the students. Now suppose, again, if I take this spherical glassy material, and if I extract this part now, okay, now it will be like this. How it will be? Let me erase this. So it will look like this. Okay. And students, if I suppose, what I do, if I polish this side, if suppose I polish this side, okay, now this will be not reflecting. This is what? This is not reflecting now. Okay. And this will be a reflecting surface here. Okay. And I will call this also a type of spherical mirror, which is what? Convex mirror. This is what? Convex mirror. Okay. Is it right or wrong? I mean, it's right. I'm asking from your perspective. Did you understood this? So now we can conclude like this. Sir, there are two types of spherical mirrors. There are spherical mirrors. There are spherical mirrors and basically two types of spherical mirrors. Concave mirror and other is convex mirror. Concave mirror and convex. Okay. Concave look like this. And convex look like this. Okay. Got it? So these are two types of spherical mirrors. Someone asked from you, what is spherical mirror? You can say like this. This is a spherical mirror. Okay. Now write the next heading. What we say, some important terms. Okay, let me project this thing on the PPT only. Okay, it will work. I put all these things. Yeah. Okay, now it will work. So what is pole or vertex? Do you want on the whiteboard on this PPT? On the PPT, I've already done the annotations. Do you want on whiteboard or on this PPT? Text anyone? PPT. See, vote. Everyone must vote here on PPT or whiteboard. So if I will count how many PPTs are there and how many whiteboards are there. I will count it. Okay. Okay. Yes. So whiteboard, PPTs. PPT only if annotate. PPT. Okay, I'm showing on the PPT because I already done some annotations there. It will save our time. Okay. I will show you the PPTs because I've already done the annotations there and it will save your time there. Got it? Okay. So see, it's like this. This is concave mirror. This is pole. Okay. This point is defined as pole. See. On whiteboard, I will show. Okay. Pole or vertex. Suppose we are having a concave mirror. Polish, 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 polish. And suppose we're having a convex mirror. Polish, 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 polish. So what you will define a pole? Pole, how the pole will look? Pole will look like this. I mean, it's a point. So see, I'm also making a notes with you. You also make. Pole is a point, center point. This point is defined as for a concave or convex mirror. This point is defined as. See, Urja, please work from whiteboard only. Okay, no issues. Because through this you will study. That is ready-made. Ready-made things doesn't work sometime. Sometime, you know. For the next time, I will do PPTs, but let us try with whiteboard today. Let us make the notes. It's fine. Okay. So pole or vertex kya hota hai? It's a center point of concave or convex mirror, spherical mirrors combinedly, if I say. Got it? Yes, students. So all the students are texting. That's good. Now next point. Kya next point? Focus. What is focus? Suppose, so it's like an offline class. Okay. Suppose this is a concave mirror. This is pole or vertex. If a line is passing from pole or vertex like this, remember first of all this thing, okay, this line is known as principal axis. Okay? And this point here is known as center of curvature. Okay? And this point, midpoint between, now before this focus, someone may ask, sir, center of curvature kya hota hai? See, center of curvature, let me tell you this thing. Let us go to the back slides. See, we took this. Okay, let us go for the concave because I'm explaining you from the concave. Okay. See, you can see this thing. A concave mirror aaya kahan se? From where it came? It actually came from, we have extracted this thing from and polished the other side of this spherically glassy material. And if it's a spherical glassy material, it will be having, of course, a center point. This center is at a distance from this mirror. I mean, you can say like this because it's initially the part of this at a R because it's center. सबसे R ही होगा ना इसका तो distance. So इससे भी कितना होगा? इस mirror से भी कितना होगा? R. Okay. So this point, whether in concave or whether if you take this convex, this point which is at a R distance is known as center of curvature, students. It is at a distance R from the pole of the mirror, whether in concave or I have just took concave for explanation. You can take convex also. Okay. And this R, students, is known as radius of curvature. Okay. And focus is a point which is in between this center of curvature and pole. R by 2. Okay. Now I'm showing the PPT. So all these points are completed or not? So we understood how many things? We understood principal axis, we understood pole or vertex, we understood focus, we understood curvature, center of curvature. Okay? Okay, so we understood all this point, principal axis, we understood center of curvature, this point, which is at R distance, basically from the pole. We understood focus point also. We understood aperture. Now let us talk about somewhat about aperture. Aperture is this point. This line is aperture, students. That if you take a concave, this is what? Concave mirror. If you join two ending points of this mirror like this, So it becomes like a bow and arrow. No? If I put an arrow here and I throw it, it will go like this, boom, 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 boom. Okay, but leave that. So this, if you connect these 2 points, you will get a line. This line is known as aperture. Okay, if you connect these 2 points, you will get a line. Fine, students. This is aperture here. Aperture, aperture. This is also aperture here. Okay. Now, students, let us go to the main part. So this is focal plane. Okay. Let me write somewhat here about the focal plane too. Yes, focal plane. Suppose you are having concave mirror. This is principal axis. This is pole or vertex. This is principal axis. This is center of curvature, which is at r distance. This is focus, which is also at r by 2. Okay, got it? Center of curvature है, focus है r by 2 पे, and this is polar vertex, and this is the principal axis here. Okay. Now, what is focal plane defined? Focal plane is defined something like this. Let me show you. Red point, and focal plane is like this. Suppose you draw a plane perpendicular to focus. If you draw a plane perpendicular to the principal axis and it passes from the focus, such plane is known as focal plane. Okay, a plane which is perpendicular to principal axis and it passes from focus point, such plane is known as focal plane. Focal plane. Okay, got this thing? Okay, so let us move now next here. Yeah, one more thing you need to understand. Now write the heading rules for image formation. Now we'll study rules for image formation. Write the heading, students, rules for image formation. Written? Okay. So here you can see on your screens that this is what? A concave mirror. So I'll explain you this point. This is concave mirror. Students, previous class may these topics were completed or not? I'm sure it's not completed. Can anyone text in the chat box? Were these topics completed or not? Anyone of you? Anyone of you can put a text in the chat box. Were these things completed or not? Yes. सिर्फ प्लेन मिरर तक ही हुआ था ना. That's fine. Good. So suppose this is a concave mirror, students. If a ray, remember always, you have to remember these all points. Remember these all points throughout your life. Okay. So suppose a plane mirror this is what a ray. Suppose a ray is incident parallel to principal axis. This ray is incident parallel to principal axis. Okay, and it is incident at a point here on this concave mirror. Then after reflection from this concave mirror, this ray of light goes from this point which is known as focus. Of course, focus is at r by 2. We know this thing. It's a midpoint of curvature and pole. We have studied this thing. Okay, if a ray of light passes, it is parallel to this principal axis. So after getting reflected from the concave mirror, it is what it is, sir. It passes from the focus. And if you now say for the convex mirror, because on the right hand side there is one mirror convex also, so we can say here, if a light is parallel to the principal axis, after reflection from this mirror, it appears to pass from the focus. appears to pass from the focus. Okay. Now next point. This is the next point I've already noted. Now it's the reversibility of the first point. That जो हमने first में पढ़ा था, that there was a concave mirror and yes, so there was a concave mirror. A ray is incident like this, it passes from the focus if ray is parallel to the principal axis. ठीक है. अब इसमें क्या हो जाएगा? इसमें it will be like this if a ray passes from the focus. अब ये reverse है, reverse of the previous statement. If a ray passes from the focus, it will become parallel to the principal axis. Or if a ray appears to pass from the focus, it will become parallel to the principal axis. ठीक है? That is what if a ray passing out through or directed towards the focus after reflection from the spherical mirror, it becomes parallel to the principal axis. This is the second point. Now, what was the third point? Third point is this, that suppose this is concave mirror. This is concave mirror. Suppose if a ray passes from the center of curvature, remember these 2 points I've already told. One is fine, another is reverse. This is a new point for you, maybe. I mean, it may feel like a new, but it's like second because second one was reverse. So if a ray now passes from, say, is incident from center of curvature towards this spherical mirror, say concave, then it will retrace its path. So it will come back along the same route. Okay. So it will come back along the same route. It will retrace its path. Okay. Next point is this. Suppose in this, I mean, based on this only concept only, that if a ray appears to pass from the center of curvature, again, it will appear to retrace its path in convex mirror case. Convex mirror case. Convex mirror case. Convex mirror. Convex mirror case. Okay? That if a ray passes from this center of curvature, it appears to retrace its path. If a ray goes from this convex mirror, appears to go from convex mirror, it will retrace its path again. The main thing is the center of curvature. Now this fourth point, suppose you're having a concave mirror. This is pole. This is focus. R/2. This is center of curvature. So we say like this. Suppose a ray is incident at a pole at an angle, say θ1. So it will reflect from that point following the laws of reflection, say θ1 again. Got it? अगर ray incident होती है concave mirror के pole पे, तो it will follow the laws of reflection and it will get reflected. Similarly, in case of convex mirror, it will do the same. If it appears to go from this like this, it will go like this. Got it? So these were the 4 points, students. Now write the relation between object distance, image distance, and radius of curvature for spherical mirror. Okay, let me explain you this thing. See, suppose students, we are having a concave mirror. Concave mirror. Okay, this is what concave mirror. And suppose we are having like this. This is concave mirror. And so this is principal axis. This is what principal axis. And suppose this is a focus point. This is curvature. And of course, this will be at r distance from this pole. Okay. Suppose, students, on the principal axis, if the object is present here at u distance from this pole, okay, and focus is given like this, okay, and they ask from you, how will you find the image? That is image distance from the pole. Okay. See, one more thing before this. Remember always, all the distance, whether in concave or convex, are measured from the pole point. Okay, so if you go here, that is against the incident rays direction. That is, this direction is against the incident rays direction. No, so you will take this direction as negative from the pole. If you go in this direction, you can take positive. You can also do like this. Suppose you take this pole point as origin. So of course, this direction is negative and this direction is positive. Okay. Yeah. So we were here. They were asking for me to find the image. So it will be like this. And this is what? This will be the formula. Remember always. No need of derivation. Just remember the formula, students. 1 by V plus 1 by U equals to 1 by F. Okay. Where F is a focus point, which is equals to R by 2. Always remember this thing. Okay. For concave mirror like this, we'll take F to be negative. Also the radius of curvature to be negative. Object distance as seen here, the red color O is negative. We don't know image, but it will come, but we'll see as per the numerical. Okay. So what's the sign and convention? Sign and conventions are this. You have to measure all the distance. This is the way, okay, to solve the question. All the distances are measured. I'm writing especially this line. In the notes, you will see all the distances are measured from pole. All the distances are measured from the pole. Okay. And let me write on the next line. Okay, this is a question. Okay. And if you go from the pole to opposite to the rays direction, it is negative here and it's positive here. Okay. Now, please be focused in the class. Please be focused in the class. I will solve this question for you first. One question I will solve. Next question you will solve. Okay. So maybe I'll give the next question as homework. But now be focused on how to solve this question. Okay. So this will be a practice. This is a class illustration for you. Mark this as class illustration. Okay. Okay. So mark this as class illustration. Take. I'm solving this question. The question is what? Question says be focused on the slides. Question is what? Question is the what? It says find the position and the type of image formed. It means they are basically asking from the second part is this, whether the image will be real or virtual. You know the difference between real and virtual? No. Real can be taken on the screen, virtual can't be taken on the screen. It's in the mirror world. Okay? That will decide with the signs. And what's the position? They're asking me the numerical number, where it is. It's here. So they're asking from you. So whether it is here on this line or here on this line. Here it will be virtual, here it will be real. Okay? So now let us solve the question. Fine. So apply the formula 1 by V plus 1 by U equals to 1 by R. One of the students have already solved the question, I think so. Very good. Varsha says, very good, Varsha. So if apply the formula C, object distance here is given as what? I told you what in the beginning, that measure all the distances from the pole. Pole here is 0, 0. This direction is negative. This is origins, of course. Cartesian coordinate mein hum padhte hain na. This is what negative. This will be positive side. This is negative. So measure all the distances from the pole. If you go from pole towards the object side, this is O means object. This is at total unit of 30 centimeters, but it is in which direction? Negative. So as per the sign and convention, I will take this U as minus 30. V I need to find. Focus is how much, students? R by 2. Okay, focus is R by 2. See, if you see the focus point also, if you see focus point also, it is also where? It is here. And if you go from pole to the, this is P pole. If you go from pole to the focus, it is negative. And focus is R by 2, it's negative, means negative ka matlab kya hua? Minus 20 by 2, that is minus 10 centimeter. So put this minus 10 here, put this U here, you will get the answer. Okay, let me solve it for you. 1 by V. Minus 30 minus how much? Minus 10. So when we solve this thing, we'll get this thing as 2 by 3 15, and this basically, okay, this is minus 2 by 3. Okay, so we'll get answer V as minus 15 centimeter. So you're getting image distance as how much? V equals to minus 15 centimeter. Okay, V is minus 15. So if I draw the image, I mean if I just show the image, ये pole है. Let me remove फालतू की rays. So I've removed this, which is creating irritation here. Okay, in drawing the image, blockages in drawing the image. See, this is the pole point or pole or vertex. You know this. You can see here, no? This point is pole or vertex. Okay, got it? If you go from the pole, this is of course negative. This is positive. That's fine. But image का answer क्या है? Image का answer है minus 15. So if you go from the pole, we need to start our journey from the pole. This is plus units. This is minus units. They are saying minus 15 units, minus 15 centimeters. It means 15 units not in the positive direction. Otherwise, it will be 5 plus 15. It is in the negative direction. So it will be here at the midpoint. So I will say image will form here. That is at 15 units on this side. That is negative. So minus 15 का मतलब ये होता है. Now this image is what? It is a real image. Okay. Yes. 15 centimeter real image. Very good. All the answers are right. Varsha, Anu, Sonali, and Ravina. All your answers are perfect. Very good. Excellent. Okay. So this was the answer. I mean, this is the solution of this question. Now we'll see the next thing. Yeah, this is the next thing here. This is what find the position and the type of image formed. Which kind of mirror is this? Again, concave. This mirror is again, students, concave mirror. Okay. And you have to find the type of image formed. So this is a homework for you. Note down this question. You will use all the things which we have studied in the previous slide. That is, you will take U here as starting from the pole. Starting from the pole, this direction is negative. This is positive. U will be what? Minus 5 centimeter. V we need to find. Radius of curvature again is negative. Focus is minus 10. Put all these values and this form. I've already solved, kind of question. I've already solved it. So I've given you the hint of more than like 70-80%. 70% hint I've given you. Okay. So put all these values here, we'll get the answer. Okay. Yes. So Sonali, I've given the right answer. That is 10 centimeter virtual image. Okay. That is what? 10 centimeter virtual. Minus means what? Minus means virtual. 10 centimeter is plus. See, answer will come as B plus 10. So plus means, you know this thing. Okay, it's a homework. Plus means in the direction of the rays in this side. So this will give you the virtual image in the mirror word, in the elusive word. Okay. Very good, all the students. So that was all about today's class, students. Thank you so much for your attendance. And now I'm launching the NPS. Please participate in the NPS. And if anybody is facing any doubt, can text me in the chat box. Okay. So I am now launching the NPS poll for all of you. NPS is started, students. I hope it's visible on your screens. Yes. So what I was saying is that if anybody is facing any doubt, can text in the chat box. Okay? Or you can leave after the NPS. Bye bye everyone. Take care and study well. So students, I'll end the poll soon. I'll end the poll soon. Okay. I'll end the poll soon. हो गया? Okay, students, bye bye everyone. I'll end it. If you are facing any doubt, you can text here. So I'm ending the live stream. Bye.